As we have seen, incorrect PCB component placement can result in very poor PCBA performance. Because these SMT placement issues can manifest themselves in vastly different ways. We will generalize them in the following 8 categories. First, signal integrity. SMT components that are not properly placed in their circuitry can create signal integrity issues that can lead to degradable performance or outright failure. PCB layout designer must place their components according to the signal paths depicted in the schematic and keep digital and analog components segregated in their design partitions. It is also important to place components in a way that allows a clear signal return path on the reference plan. 2. Power integrity is another important consideration in a circuit board's performance. Bypass capacitor must be placed close to the power supply pins to reduce the chance of noise in the supply network. Power components need to be placed closely on the same board layer to keep their connecting traces short and reduce inductance in the traces. 3. PCBA rework components of the PCB manufacturing process includes reworking the circuit board during assembly, whether it is inspection or actual repair or replacement of parts. Placement of SMT parts hidden within larger parts will make rework and inspection difficult. Repair and test tools may not fit where they are needed, causing collateral damage to nearby components. 4. Testability. SMT components placed too close to inline test points can prevent test probe access. Another problem arises if the SMT part is placed over one or more test points, thereby completely obscuring their test points. 5. Soldering small surface mount components on a wave soldering board might not receive the required amount of solder if they are preceded by a larger component entering the wave soldering process. This effect is called shadowing. Designers should try to place smaller components in front of larger components to avoid this situation. 6. Tombstone effect. When a small two-LED SMT part is passed through a reflow oven, the thermal imbalance between the two pads can cause the part to pull up from one pad and stand up straight like a tombstone. Pads can cause thermal imbalance in the PCB footprint. Different size traces connected to the pads or having one of the pads embedded within the metal area field. These conditions will act as a heat sink, causing the solder paste on the outside pad to melt faster and pull the component toward it. 7. Insufficient solder. SMT parts can also fall victim to insufficient solder during assembly, resulting in poor solder joints that can break or form intermittent connections. If the pins are not perpendicular to the wave soldering direction, insufficient solder might also occur during the wave soldering process. This problem can also occur during reflow if the parts pads are not large enough to hold enough solder paste to form a good joint. 8. Solder shorts and bridging. SMT parts can also contain too much solder that bridges one pad to another, creating an electrical short. Bridging can also occur if the PCB package pads or solder paste masks are created incorrectly, or if components are placed too close to each other. When you work with POE, you get years of experience on your side, timely service, and product excellence. To learn more about how our PCB assembly service can help you meet your goals, contact us online. Call us at 0755 2531 2250 or request a free, no obligation quote today.